I have a problem. I've recently regained access to the apple orchard that supplies all of my food, after temporarily losing it due to a rock slide. I was able to ration out the apples that I had left over the time that it took to clear the path, but now I'd like to figure out how to better manage my apple supply in case something like this happens again. What makes this somewhat difficult is that, a while ago now, I forgot all of mathematics. Differentials, differences, diffusion processes. Whatever math I need to manage my apple supply, I'm going to have to rebuild it from scratch. Over the last few months, I've managed to rebuild a number of mathematical tools I might be able to use, including addition, subtraction, multiplication, and division. I've managed to prove a number of things about them, which I've recorded in a document I'm using to keep track of my progress. It's good to keep on hand, in case I forget what some word I've come up with is supposed to mean, or how a process is supposed to work. The first thing I want to do is to get a better understanding of how quickly I can gather apples. I know from experience that I would normally gather about 24 apples in a day, but this was before I was concerned with building up a stockpile. If I wanted to gather as many apples in a day as I could, how many apples would that be? Since I haven't been here in the orchard in almost a month, the trees all seem to be pretty well stocked with apples. These trees generally tend to grow new apples every few days up until they're, well, I guess, full? I'm not sure what the proper botanical term would be. Looking around and counting the apples on each tree, it seems like most of the trees here have between 6 and 8 apples on them. I guess the fastest way to gather apples would be to pick every apple from a tree, then move to the next closest tree and pick the apples from that one, and so on. How long does it take to pick all the apples from a tree? I've thought about how many apples I can gather in one day. It definitely takes me less than a day to pick one apple, but I haven't figured out how to keep track of amounts of time less than a day just yet. Is there anything that I know I can do exactly some number of times in a day? Now that I think about it, there's this thing that I have back at the house that I don't really know what it's for. It's got some things on the front of it that kind of spin around, and it does seem like each day they end up in the same place. The bigger one definitely spins around faster than the smaller one does. I'm pretty sure the smaller one only spins all the way around twice each day, but the bigger one spins around, I think 24 times. If these things always take the same amount of time to spin around, I can use them to keep track of amounts of time shorter than a day. I still need to check and make sure that's actually true, but if nothing else, it gives me ideas for how these shorter amounts of time could work. The bigger thing spins around 24 times in a day. I'll say that the amount of time it takes to spin around once is an hour, and so each day is made up of 24 hours. I can bring that thing down from the house and check how many apples I can gather in an hour. Then, since there are 24 hours in a day, the amount of apples I can gather in a day would be 24 times that amount. Although, realistically, I wouldn't be gathering apples for an entire day. A good chunk of it is actually night, after all, and I don't really like to gather apples when it gets dark out. Also, I'll often have other things that I need to do throughout the day. How much of the day can I spend gathering apples? The obvious thing to do would be to just spend a day checking, but I'm a bit curious. I feel like I know enough about math now that I should be able to figure this out. I know that the reason the sun comes up and goes down is because the Earth spins. I've forgotten all of mathematics, but still remember my astronomy. A day is the amount of time that it takes the Earth to spin around once. So, how much does the Earth spin around in an hour? I don't really know how to deal with this in terms of numbers. The only thing I can think of is the connection I've noticed between division and multiplication. I know that if some number a divided by some number b is c, then c times b is a. The Earth spins around one time in 24 hours, so the amount that it spins around times 24 would be 1. This isn't a thing that can happen, at least with my current definition of numbers. Although, in fairness, I'm also not completely sure what exactly it is I'm counting here. How would I count an amount of the Earth spinning around? I'm kind of having flashbacks to what I did the very first day after I'd forgotten all of math. I spent a while trying to figure out which sorts of things I could count, which included things like frogs, apples, and also things like lumps of clay or buckets of water. I came to the conclusion that I couldn't count clay or water directly, but that I could count lumps of clay, as long as the lumps were the same size, and buckets of water, as long as the buckets were filled the same amount. If I think of days as being times the Earth spins all the way around, then I kind of have a similar situation. On the one hand, I have this idea of a day being 24 hours. I can think of it in a similar way to a box of 24 apples, and count days as boxes and hours as apples individually. But on the other hand, if I think of counting days as counting times the Earth spins all the way around, I also have an understanding of the Earth spinning less than all the way around, just as I do of a lump of less than 1 pound of clay. Once again, I'm encountering this fundamental distinction between things that can always be split into smaller parts and things that can't. I think it's worth having words to describe these two situations at this point. I'll say that things like clay and water, and probably time, are continuous. I can always split a lump of clay into smaller lumps of clay, or an amount of time into smaller amounts of time. Meanwhile, things like apples and frogs, I'll say, are discrete. If I have one apple, I can't split it apart into more smaller apples. Any attempt at doing so would just result in pieces of apple, or possibly applesauce. Numbers, as I've been defining them so far, work very well for counting discrete objects. I can add, multiply, divide, and subtract numbers of apples just fine. They also work when describing what I'll call discrete amounts of continuous objects, like water and clay. But they fail when trying to count continuous objects directly. There is something of a workaround to this. I said before that I can always split a lump of clay into smaller parts, but in practice that's not really true. I know that clay is made up of a mixture of soil and minerals, and if I were to keep splitting lumps of clay, I'd eventually end up with, I guess, just a single particle of rock or dirt and be unable to split it any farther. I'd stop being able to even see the lump of clay I was working with long before I reached that point. Clay is technically made from discrete particles, but it's extremely impractical to try and treat it that way for the purposes of counting. That said, for any given reason I might want to think about how much clay I have, there's probably some least amount of clay that I can think about, where any less clay might as well be no clay. If I were trying to plaster over a hole in the wall, for example, and trying to find out how much clay I needed, I could say there are maybe 7,000 grains of clay in 1 pound of clay. And less than a grain of clay almost definitely won't make a difference to whether I successfully seal a hole or not. Putting all of this together, while I still definitely need to think more about how I might be able to count continuous things like clay and time, I think for now, if I come up with some small amount of time that I can consistently keep track of, I should be able to treat it like some smallest amount of time that matters, and use it with my current system without worrying about it being very slightly too long or too short. Looking back at that spinny thing from earlier, I feel like I should call it a clock for some reason. There's another thing spinning around in between the bigger one and the smaller one, and that one seems to spin around about 60 times each time the bigger one spins around once. So, I guess I'll say that an hour has 60 minutes in it. At this point, I think I'm ready to go back to thinking about how long the sun stays up during the day. I'm pretty sure the Earth shouldn't spin any slower or faster during any given minute, or hour for that matter. And if it spins the same amount each hour, and I start keeping track at dawn, there should be about 12 hours of daylight before the sun sets again. Now, I know this isn't going to be exactly right. The Earth is tilted a little bit relative to the sun, so given where I live, the day will last a bit more or less time depending on the season. But since I'm just trying to find an approximate value anyway, it should be fine. If I suppose there are going to be at least 8 hours in a day that have enough light for me to work, and that I'll need maybe 2 or 3 of those hours for other things on any given day, I can conservatively say that I can comfortably spend 4 hours in a day picking apples in the orchard. As for the amount of apples I can pick in that time, now I should go back to using minutes. I can pick a lot of apples in an hour, but I know that I pick a lot less than 60 of them. I'll need to experiment a bit to find out exactly how many minutes it takes me to pick an apple, but until I do that, I can make a rough estimate and say that it takes me about 2 minutes to pick an apple, and maybe 5 minutes to move from one tree to another. If those guesses are close to correct, then it should take me between 17 and 21 minutes to pick all of the apples from a tree and then move on to the next one. Again, being conservative with my estimates, I might guess that I can gather 6 apples every 20 minutes. Since there are 60 minutes in an hour, I can divide 60 by 20 to figure out how many times 20 minutes can fit into an hour, and get 3. Therefore, in an hour, I should be able to gather about 3 times 6 apples, or 18 apples. And so if I gather apples for 4 hours in a day, I should be able to gather about 72 apples. This might just be an estimate, but it's a very encouraging start. I generally eat about 12 apples in a day, so if I eat 12 and gather 72, each day I could build up my stockpile by about 60 apples. It would only take about 7 days to build up the 420 apple stockpile I'm currently aiming for at that rate, which could keep me comfortably fed for at least a month. I think this is about as much as I can do without trying some actual experiments. So, over the next few days, I'll try to answer some of my questions about how long things take, and next time I can start putting that information to use. Meanwhile, I have this question of continuous versus discrete things and how I might be able to count the former. I've said before that while the version of numbers that I have right now works very well for counting discrete things, it's definitely worth considering the possibility that there's some other version of numbers that could work for counting continuous things. I don't know if that's something that I'm going to need right away, but I should keep it in the back of my mind whenever I run into similar problems. I'm thinking that, for now, when I'm counting these discrete amounts of continuous things, I should use a specific word for it. I'll say measuring. I can measure time using days, hours, or minutes. Depending on what it is that I'm trying to measure, any one of those might be the right thing to use. I'll say that these are all units, and while I'm at it, I can think of pounds as being a unit with which I can measure clay. I'll try to come up with more units for things as they become necessary. It feels like a good idea to have different scales at which I can measure things. Sometimes I want to keep track of days, while sometimes I really need to keep track of minutes. For now, though, I'm satisfied with the progress I've made today.